right, today we are going to start working on simplifying expressions with rational exponents. And rational is just a fancy word for fraction. So rational exponent says exponent that can be written as a fraction. And I just have a review here of all our exponent properties that we've discussed so far in this unit. So I'm going to scooch this up a little bit so you can see the table. What I have here in each of these examples next to the properties, these have integer exponents, and then example 2 for each has a rational exponent. So we're just going to kind of compare the difference and go through. So if you multiply like bases, like 2 and 2 here, you add the exponents. So this would be 2 to the 7th. Works the same way if you have rational exponents. This one, if you are adding or subtracting, you do need a common denominator. Now, I do have that in the case of my example there. So I would add 1/3 and 2/3. This would be 8 to the 3/3 power, or that would just be 8 to the 1st, or just 8. So same rules apply, but if you are working with rational exponents, you do have to have a common denominator. Power to a power, you multiply the exponents, so this would become 2 to the 12th. In the case of a fraction, if you're multiplying a fraction and a number together, you do not need a common denominator. If it helps in any way, you can always turn a plain number into a fraction by writing it over 1. So this problem would become straight across the top, straight across the bottom, 5 to the 4/2, which would be 5 squared if you simplified it, which then, if you can further simplify that, it'd be 25. Product to a power. Product here, these two being multiplied, it's like a little bit of a distributive property. Notice I just have multiplication in there. I don't have any adding or subtracting, so you can do this. So this example would become 2 to the 3rd and x to the 3rd, or if you want to simplify that, 2 to the 3rd power is 8, so it'd be 8x to the 3rd. Okay, both of these are going to be multiplied together to the 1/2 power. So 64 to the 1/2 times 25 to the 1/2. We're going to get into this a little bit further down with how to simplify numbers with exponents there in a second. This actually might not make sense at the moment. I'm going to grab a different color here. But just so you guys have this in your example, 64 to the 1/2 power is actually just the number 8. We'll go over it in a second. 25 to the 1/2 power is just 5. The 1/2 power is the same thing as a square root, and so the answer there is actually just going to be 40. And we'll get into that more in a second with how do you go ahead and convert an exponent to help you simplify a number. But for the moment, let's just keep going with the properties. Okay, negative exponent. This one would be 1/2 to the 3rd, or 1/8. Same thing with your fractional exponents here. This would be 1/9 to the 1/2. And we're going to get into this in a second again. I'll just go ahead and write the answer there. That would simplify to be 1/3. The 1/2 power is the same thing as a square root. Opposite, if the negative exponent's in the bottom of the fraction, move it and lose it. We're just going to move it to the top. So this would just become 2 to the 3rd, or just a plain 8. Same thing with variables. This is going to move to the top, even though it's got a rational exponent. This would just be x to the positive 1/2 power. If you are dividing like bases, you subtract the exponents. And so here I would just do 4 minus 3. This would be 2 to the 1st, or just a 2. Again, if you are adding or subtracting fractions, which we're going to do with these rational exponents, you do need a common denominator. So for this problem, we already have this. This is pi to the 3/2 minus 1/2. So that would end up being pi to the 2/2. I do already have a common denominator there, which would just be pi to the 1st, or pi if we get that totally simplified. And then finally, I have a quotient to a power. This is similar to product to a power. Anything inside the quotient there is going to have that exponent on the outside distributed to it. Again, notice I don't have any adding or subtracting, so I could do that. So my example with integer exponents, this would be 2 to the 3rd over x to the 3rd, or if you want to simplify the top of that, 8 over x to the 3rd. Here, if I have a rational exponent, same concept. I don't have like bases, so we're not going to simplify in that manner. This would be x to the 1/3 over 27 to the 1/3. And we're going to get into this in 1 second here. 27 to the 1/3 power. That doesn't really look like a 3. 1/3 power is the same thing as a cube root, so this could actually be simplified x to the 1/3 over 3. And like I said, we're going to get into this more in a second. So my first example, we're actually going to simplify these as much as possible. If you are doing any adding or subtracting of exponents and you have rational exponents, you do have to have a common denominator. So my first question, this would be, I have like bases, the 2 and the 2, so I'd have to subtract here 4/5 minus 1/3. So we got to figure out a common denominator there. Lowest common denominator between those two, I think, is going to be 15. So it's probably been a minute or two since you've done this, and we are going to ask you guys to do these questions without a calculator. You'll notice that in the directions. So here I would multiply top and bottom by 3. Here I'm going to multiply top and bottom by 5. That'll give me a common denominator. So my problem is going to turn into 12/15 minus 5/15, and then we can go ahead and subtract. Now the denominator stays the same, and you go ahead and just subtract the numerators. So 12 minus 5 would be 7. So ultimately, after I get a common denominator, I can answer the question. This would be 2 to the 7/15 power. Similar concept, if you're going to multiply like bases, you're going to add the exponents. This would be 1/2 plus 3/8. So again, if you're trying to create a common denominator there, I would tell you that 2 goes into 8, so I really only need to do multiplication on that first fraction to create a common denominator. So 1/2 is the same as 4/8 plus 3/8. And then all total, that would give me 7/8. So my answer there would be 7 to the 7/8 power. And then we're just going to do a couple at the bottom here that don't look like they have like bases, but we can create them. Okay, so here's where I would grab my little list of perfect squares, perfect cubes, all those types of numbers if I'm not familiar with them. And I don't have like bases as this is presented, but what I want to do, I'm going to rewrite 25 as 5 to the 2nd power. You'll notice that 5 squared is 25. So I'm just going to rewrite this real quick. 5 to the 1/3 times. Instead of 25, I'm going to write 5 squared to the 1/3 power. And I'm going to use my power to a power to just simplify these exponents real quick. 2 times 1/3, this would end up being 5 to the 2/3 power. And then in that case, I'm multiplying like bases. I just add the exponents. This would be 1/3 plus 2/3. We don't need to create a common denominator. We already have that. This would be 5 to the 3/3 power, or just 5 to the 1st for that question. Same concept here. I'm multiplying, but I don't have like bases. So I want to try to find 16. Here's 16, and I could write it as 4 squared, but that's not going to help me out here. I would also notice I got a 16 down here. This is a 4th root, so 2 to the 4th power is 16. So that's what I'm going to use to rewrite here. So keep that 2. I want the like base. So I'm going to write this as 2 to the 4th. That's 16 to the 3/4. And we are multiplying like bases then after I simplify this a little bit. If I do 4 times 3/4, just don't need a common denominator there, that'd be 12 over 4, which would actually end up being the nice number of 3. So this is 2 to the 1/2 times 2 to the 3rd. Now, to simplify this, I do need to add 1/2 and 3 over 1. So let me just convert that so it has a common denominator. I would multiply the top and bottom there by 2 to give me a common denominator. Be 6 over 2. And I know that simplifies back to 3. Just leave it that way so we can add those exponents together. So this would be 1/2 plus 6 over 2, which is going to give you 2 to the 7 over 2 power. A lot of little intricate steps in these questions. And I've got one more here to practice. This is 3 to the 1/2. 27, if you want to come back here, find the 27. This is in your third root column. This is 3 to the 3rd power. 9 is 3 squared. This is 3 to the 3rd. So I'm going to rewrite 27 to get my like base as 3 to the 3rd. All right, and so this is 3 to the 1/2. Power to a power, we're going to multiply the exponents there. If I do that, I'm going to get 9 over 4. So I'm doing 3 times 3/4, just multiply straight across the top, straight across the bottom. That's where that's coming from. I do need to add these exponents together, so we need a common denominator. So 1/2 plus 9/4. What I would recommend there, let me just multiply top and bottom of that fraction by 2 to get a common denominator of 4. So I'd get 2/4 plus 9/4, which would simplify all in total till 11/4, and that's going to be our answer, 3 to the 11/4 power. All right, and another major component of this is going to go along with my second example here, and it's going to be related to my definition at the top. So we're going to convert what's called exponential form, because I have an exponent, into radical form to help us simplify these expressions, and I was talking about this a little bit at the beginning. I call this bottom out, and the reason for that is the denominator of your fraction is going to be the index of a root. So let me show you how this works. This is exponential form because I have an exponent. Radical form is going to have a root, like a square root or a cube root of something like that. So here, bottom out, b would become the index of your root, and then a is going to be the exponent. There's actually two ways you can write this. The bottom out always works though. The denominator becomes the index of the root, but there's kind of two different schools of thought of how you can write this. You can put the exponent on whatever's under the radical, or you can put the whole radical in parentheses and the exponent outside. Both of those are technically correct, and we're going to get into this in this example. If you guys remember me telling you this on the front, I'm going to do the bottom out. 1/2 power is really the square root. So this would be the square root of 64 to the first. Anything to the first power is just going to remain there. So really this is just the square root of 64, which is 8. Notice I'm not putting a plus and minus in front of this because the root is in the problem, so we just go ahead and assume that it's going to be the positive unless you have a negative in the problem. We'll get into that in a second. So each one of these you want to try your best. If you want to check with the calculator, you can, but we're going to ask you on tests and quizzes of this to have no calculator available to you on these types of questions. So you want to be able to do this by hand. You, of course, can use this lovely little piece of paper to help you if you're not familiar with some of these numbers, and that's what we're going to get into as we go through here. All right, so bottom out, this would be the square root of 4 to the 3rd. So there's a couple ways you can do this. I usually recommend taking the root first because that will probably cause you to work with a smaller number, but it's completely up to you. I'm going to do it that way in this problem. So this would be the square root of 4. The square root of 4 is 2, and then to the 3rd power. So the answer to that question is actually also 8. So I would recommend taking the root first. This one, bottom out, this would be the cube root of 216 to the 1st. So just the cube root of 216. If you guys are looking at, oops, sorry, I'm making the screen too big. Maybe we could just go ahead and go from here. But if you're looking at your list of perfect squares, cubes, and everything else, 216, the cube root of that is just going to be 6. So that's going to be a nice number there. Let me go ahead and blow that back up so we can see that better. Okay, now the only thing that's going to be different here, this is a negative exponent, so this is 1 over 125 to the 1/3 power. Move it and lose it. I created a fraction there and I'm moving that to the bottom. So this is 1 over the cube root of 125 to the 1st, which would just be the cube root of 125. Also on that list, this is going to simplify to just be 1/5. Okay, now, not a negative exponent. This is a negative number, so we're not going to involve a fraction here. Bottom out, I'm going to do the cube root of negative 8 squared. So 2 schools of thought. I would take the cube root first. You could do it like this, or you could do it like this. We should get the same answer. You got to be careful here. Okay, if I take the cube root of negative 8, in both instances, I should get negative 2. And then this is where you have to be careful. So I'm doing the cube root of negative 8, and then I'm going to square that. So when I square that, this is actually going to cancel out the negative, and that's going to become positive 4. So make sure you pay attention to that. You can take the cube root of a negative number, but when I square that, that's what's going to cause that to be a positive 4. All right, kind of a similar concept. This is the cube root of negative 27. And then that's going to be squared. Again, I would probably recommend just do the cube root first and then square the answer. That'll make the problem easier to do. So the cube root of negative 27 is going to be negative 3, and then I'm going to square that, so I'm going to get 9. And then I got a couple other just like little interesting technicalities going on in the next couple of examples. If you're not sure and you have a decimal instead of a rational exponent, I can go ahead and turn that into a fraction really easily. So this would be 1 over 25 to the positive 1.5 power, just to take care of that negative exponent there real quick. 1.5, I've got the tenths place, so I'm going to do this as 15 over 10. All right, so 1.5 is the same thing as 15 over 10, which if you reduce that, that's 3 over 2. So I'm just kind of using some properties that hopefully you guys remember from fractions and decimals. So this is 1 over 25 to the 3 over 2 power. So it'd be 1 over the square root of 25 and then cubed. If you do the square root of 25, you're going to get 5. And then I'm going to take that to the third power. So 5 to the third power would end up totally simplifying this to be 1 over 125. Next one, bottom out, fourth root of 16 to the third. Again, I would do the root first. So the fourth root of 16 is 2. And then we're taking that to the third power. So my answer there would be 8. The next one's pretty similar to the one I did with the decimal. I've got 8 tenths. So I'm going to write 8 over 10, which would reduce to 4/5. So this is negative 32 to the 4/5 power. I'm going to convert that to radical form. So I'm going to bottom out the fifth root of negative 32. And I'm just going to do the root first. So I'm going to put that on the outside. Now, if you guys are looking here in the column with the perfect fifths, 32 is right the second one down, so it's 2 to the 5th power. So if I take the 5th root of negative 32, this is negative 2. And then to simplify that totally, I got to take that answer to the 4th. Now, a 4th power is going to cancel the negative. Anytime you've got even exponents, it's going to cancel that out. So this is going to be positive 16 as my final answer. All right, and then I got one more. Power to a power, we're going to multiply the exponent. So this would be 4 to the negative 3 over 2. To take care of the negative exponent, it's going to be 1 over 4 to the positive 3 over 2. And then if you guys back up just a couple in this example, we already did 4 to the 3 over 2 power here. So this is just going to be 1/8. And then all we're going to do in the last example down here is just convert some expressions. Again, they're not going to have a calculator to be used, but these won't be able to be quite as simplified as what we just did. We're really just practicing here in this last example how to convert an exponential expression to a radical form. So all of these are exponential expressions. They have exponents. I'm just going to rewrite each of these in radical form. So just doing the bottom out thing, we just won't be able to simplify like we were in the other problems. Could write it like this, or you could just write square root of x. 1/2 power is always the same thing as the square root. 1/3 power, bottom out, this is the third root of x to the first, or if you want to just write the cube root of x, 1/3 power is the cube root. two ways to write this one. We could do bottom out 4th root of x to the 3rd, or you can do like I told you guys at the top with the definition, put the 3rd power on the outside like that. It's completely your choice. And I'm going to do one more bottom out. This would be the square root of x to the 3rd. You could just write this without the index in there, or you can write square root of x and then to the 3rd power. All those are acceptable answers. And I got a couple more at the bottom. We've got some products to powers here. So when I multiply inside the parentheses, what I need to do with the exponent outside is distribute that. So this would be x to the 1/2, and then y to the 2/2 power. Now I'm just going to leave it like that for a second. These are not like bases. If I want to convert this to radical form, both of these have a 2 bottom out. This would be x and then y squared. Okay, now you got to pay attention here. You might be able to simplify these, and it's just going to kind of depend on the question. But I can take the square root of y squared. I can pull a y out in front of this. So sometimes this might happen, but my answer here, this would be y times the square root of x in radical form. And I'm just going to kind of pay attention to that as I go through here. So power to a power, we're going to multiply the exponents. This would be a to the 10/3. This would be b to the 14/3. So I'm going to bottom out that. So this is the cube root, a to the 10th, b to the 14th. Now, both of these numbers we can break down under that radical. So this is a good review here. I need the biggest exponent that would be divisible by 3. So I'm going to rewrite that as a to the 9th times a. And I'm going to rewrite that guy as b to the 12th times b squared. And just see what you can take out. Perfect cube. This would come out as a to the 3rd. This would come out as b to the 4th. So my answer for that one in radical form, a cubed b to the 4th. And then left under my cube root, I have an a and a b squared. So sometimes these can be simplified, sometimes they can't. It just kind of depends on the question. And we'll just practice one more. This would be x to the 15/2, 3 times 5/2, and then y 30/2. I'm going to leave it in that format just for a second. Bottom out, this would be the square root, x to the 15th, y to the 30th. If you can break it down, you want to go ahead and do that. X to the 15th, I would do x to the 14th x. Y to the 30th, I'm going to leave alone because I can take and divide that exponent by 2. This guy is going to come out x to the 7th, y to the 15th. Now this x is still going to be left underneath. So when I write my answer here, I'm going to have x to the 7th, y to the 15th, and then an x under the square root, and that is your radical form.